This video focuses on fish nutrition and growth performance parameters. Growth, health, and reproduction of fish and other aquatic animals are primarily dependent upon an adequate supply of nutrients, both in terms of quantity and quality, irrespective of the culture system in which they are grown. In aquaculture, fish rely entirely on externally provided, nutritionally complete feed throughout their cultivation cycle. Diets including marine and terrestrial ingredients are precisely formulated to meet nutrients and energy requirements of the species and life stage. For example, very young fish have higher requirements for protein in the diet, both in terms of quantity and quality. A successful fish feed must not only meet nutritional requirements, but also be water stable and readily accepted by the fish. Processing is essential to achieve the desired physical properties. Commercial fish feeds are typically available in dry pellets forms, with sizes tailored to the fish species and their developmental stage. For example, early life stages require very fine feeds, like microdiets measuring from around 100 to 500 microns, to ensure easy ingestion and assimilation. As fish grow, their mouths develop, allowing them to consume larger feed forms, such as pellets of several millimeters in size. By providing fish with appropriate feed size in the correct quantities and frequency, we can ensure they eat safely, maximize feed efficiency, and minimize feed waste, thereby preventing water pollution. A very important aspect is to carefully consider the amount of feed administered at each meal. Aquaculture operators meticulously record feeding procedures and fish growth rates. These data are used to refine feeding strategies and optimize growth performance. In aquaculture, two feeding modes are generally employed. In the first, the fish are fed ad libitum, which means until satiation, while in the second, a fixed feed amount is calculated according to the fish biomass. In ad libitum feeding mode, fish are fed manually by an operator. The operator observes the fish and administers feed until the fish exhibits signs of being full, ensuring no leftover feed remains. At the end of the meal, the operator records the feed quantity consumed by the fish. In fixed ration mode, a feed ration is established based on different parameters such as fish size, genetics, and environmental factors, following an established feeding table. At the end of the meal, any feed leftover is collected and put in the oven overnight. The following day, the leftover is weighed and recorded. This operation is necessary to calculate how much feed has actually been consumed. To monitor fish growth and feed efficiency, fish are regularly weighed and the amount of feed ingested is always recorded. Thanks to this data, it is possible to calculate growth performance indices. These indices help to understand how well animals convert the feed they consume into body mass. One of the most important indicators to achieve optimal growth is feed intake, which is calculated based on the feed consumed correlated with fish biomass. This measure provides valuable insights into the feeding behavior and nutritional status of the fish, allowing for adjustments in feeding practices to optimize growth rates and minimize waste. Feed intake is calculated as the percentage of the feed ingested on the mean weight divided the number of days of the observations. The specific growth rate is a key performance indicator representing the percentage increase in body weight per day over a specific period. By monitoring the specific growth rate, aquaculture professionals can evaluate the effectiveness of feeding regimes. A higher specific growth rate indicates more efficient growth. On the other hand, a lower specific growth rate may signal potential issues such as low feed intake, suboptimal nutrition, or poor water quality. Specific growth rate is calculated as the percentage of the natural logarithm of the final body weight minus the natural logarithm of the initial body weight on the number of days between the initial and the final weight. Another index used in aquaculture is feed conversion rate, which indicates the ability of an animal to convert the diet into body weight under the reared conditions. It is stated as the kilos of feed required to produce 1 kilo of fish biomass. A lower feed conversion rate indicates more efficient feed utilization, meaning the fish convert feed into body mass more effectively. This efficiency is crucial for both economic and environmental reasons. Reducing feed costs directly impacts the profitability of aquaculture operations, while minimizing feed waste helps to reduce the environmental footprint. Feed conversion rate is calculated as the weight of feed consumed on the weight gained. In sea farms, an operator on a motorboat approaches a safe cage and feed is dispersed to the fish manually or using an air-powered feed distributor. Feeding on a farm represents a key management practice essential for optimizing growth, health, and productivity. For this reason, a well-planned feeding strategy is paramount for ensuring the success and sustainability of aquaculture farming.